Welcome to A Level and AP Physics, a place where you can improve your understanding of physics with confidence. In today's video, we will solve one complex DC circuit problem using Kirchhoff's laws. If you didn't see my previous videos on KCL means Kirchhoff's first law and KVL Kirchhoff's second law, please go back, search the channel for KCL and KVL and watch those videos first. Because in those videos, I explain the basics of KVL and KCL. So in this lesson, we will focus on complex circuit problems using Kirchhoff's laws. Here is our complex DC circuit problem. So as you can see here, there are two batteries in this circuit, battery 1 and battery 2. This kind of question we cannot solve without Kirchhoff's laws. Means we need KVL, we need KCL, we have to use them together to solve this kind of problem. So this type of problems also called DC circuit problems, means complex DC circuit problem. So as you can see here in this question, we need to find I1, we need to find I3. So we have to find this. So you can see there are three unknown. It means we have to find three equations. So the number of unknowns you can see here, there are three unknowns. So we need at least three equations to find all the unknowns. So we need three equations. So let's try to answer this now. So we will use KCL and KVL. If you are not clear about KCL and KVL, please go back, search the channel for KCL and KVL, watch them first, and then come back and try to answer this question. Okay, so first of all, we have to label all currents. So what simply it means that you have to draw these small arrows. So you have to draw these small arrows as I have already drawn for you here. So this is first thing you have to draw. You can choose any direction, but if you choose wrong direction, your answer will be minus. So that will simply tell you the direction you have chosen that is wrong, I mean that is opposite. Okay, next thing what we need to do is we need to write down the junction equation. So where is the junction? You can see this point is called junction point. So you can see in this case I1 is entering and I2 is also entering. So I entering has to be equal to I leaving, and this is based on KCL. So this is what we have written here. We can call node or we can call junction. This is one step. Always you have to do this one for complex DC circuit problems. Next one, we have to choose loop. We have to choose one loop. You can choose any loop and any direction. You can go in a loop clockwise, you can go in a loop anti-clockwise, it doesn't matter. So it's up to you, it's your choice. Okay, next step, we need to write down the equation. We need to write down equation now. So you can see, as in this case I have chosen the left loop and I have chosen direction is clockwise. So if we start from this point now, from this point we cross the battery, we go from negative terminal to the positive terminal, we gain voltage, so it has to be positive. So let me little explain to you first of all about this, because this is the key concept for KVL, so you have to be very clear. For batteries, when we will take voltage is positive, when it is negative. And for the resistor, we also need to understand when the voltage is gained or when the voltage is lost. For example, we have this battery, one terminal is negative and one terminal is positive. So if we go from negative terminal to positive terminal, we will gain voltage. If we go from negative to positive, we will gain voltage. For example, in this case, in this direction, V will be plus. But if we go from positive to negative, V will be minus. For resistor, we also need to understand this convention. So this is our fixed resistor. Let's say current is flowing in this direction. So if we go in the same direction, means we go in this way, we will drop voltage will be minus. And on other hand, if we go in opposite direction of current, so V will be plus. V will be plus. So let's look at this question now and try to understand and apply this rule here now. If we go from negative to positive, let's say in this direction, so V has to be positive. As you can see here, it is positive. Now, if we go in direction of current across this resistor, so it has to be negative, as you can see here. So that's the reason this one is negative. Now, if we go in opposite direction, let's say we go in this direction, so this is how we will complete this loop. This is our loop. If you're not clear about concept of loop, you can go and search for KVL, where I have explained KVL in detail. So next one, if you go in direction opposite, means in opposite direction of current, so you can see it has to be positive, as I have explained to you here. So this is how we have written this equation for loop 1. Next one, loop 2. In this case, we have chosen loop 2. You can see here, this one is our second loop we have chosen here. So let's start from this point. We have to go clockwise. So this is our loop number 2, as you can see here. So when I cross this resistor R2, this is in direction of current, so that's reason it is negative, in direction of current. And now you can see we have current I3, and this is passing through this resistor, and also we are going in direction of current, so it has to be negative. And also we are crossing this battery from positive terminal to negative terminal, it also has to be negative. So we have written equation. You can see here we have 1, this is junction equation. We also have for loop 1, and also we have for loop 3, we also have equation now. So you can see here we have 3 unknowns and we have 3 equations. So we just need to solve them and we can find the answer. And so that's all. This is the whole physics you need to understand for this type of problem. The rest is just simple mathematics. Let's put in actual numbers now and then try to find numerical values for I1, I2, and I3. So as you can see here, so we have battery E1 that has 20 volts, and we have resistor R1, its resistance is 5 ohms. We have resistor R2, its resistance is 10 ohms, and we have resistor R3, its resistance is also 10 ohms. And this is our second battery, it has 2 volts. Now, as you can see here, these equations are coming from the previous slide. I simply replace E1 with 20. As you can see, E1 is 20, E2 is 2 volts, and R1 is 5 ohms, R2 is 10 ohms, and R3 is also 10 ohms. There is no any change. Same circuit, we just plug in numbers here. No any other change. So let's try to answer now. Okay, next step. As you can see here, I have already written for you. So what I did here, I use I3, means I3 is equal to I1 plus I2, and in equation 3 here. So simply what we did is, this is minus 2 minus 10 I2 minus 10. So I3 is equal to I1 plus I2, and this is equal to 0. So you can see this is minus 2 minus 10i2. If we solve this one, we will get minus 10i1 and minus 10i2. If we just simplify this one, you can see we have minus 10i2 minus 10i2. So we can simply say minus 2 minus 20i2 and minus 10i1 is equal to 0. We can simplify and we will get this one. So as you can see, I have written minus 10i1 and minus 20i2, and we just place 2 on the other side, on the right side. So on left side it is minus, on right side it will be plus. It's a very simple math concept. So this is how we have got this one by rearranging. Okay, next one, as you can see, equation 2 actually. For equation number 2, as you can see, this is over equation 1, and this one is 2, and this one is third. So for equation 2, we simply little rearrange. So let me little explain to you what is happening here. So you can see this is 20 minus 5i1 plus 10i2, and this is equal to 0. So what we did is we simply took this on the left side, this on the left side. So this is on the left side, we just took on the right side. As you can see here, this is minus here, so on right side this will be plus, and this has to be minus. So this is what we have done, and we just rearrange this and we got this is over next form of equation 2. So this is just by rearranging. So this is just by rearranging we have got next equation. Now let's move on to next step. Okay, so here are the last few steps. So you can see here we have this equation from the previous slide, and now we multiply the next equation by 2 and we got this equation. So as you can see here, next we're gonna add these two equations. So you can say this can be equation number 4 and this one is equation number 5. So we are adding these two together now. As you can see, this is minus 10i1 and this is plus 10i2. So we can simply cancel these two. And we have minus 20i2, minus 20i2. So this become minus 40i2. And you can see 2 here, 40 here. So this is also 42. And then we can solve for i2 and we got this is our answer. i2 is equal to minus 1.05 amps. So this is minus is simply telling us current is flowing downwards, is not upwards. So this is what minus sign is telling you. So next step, you can see here on the previous slide we have equation for the left loop, that was 5i1 minus 10i2, and this was equal to 20. Now we just plug in value of i2. As you can see here, I plug in value of i2 and we got i1 is equal to 1.90 amps, mean this is according to our previous selection. We said i1 is entering into this loop and that is according to our that selection. That's all. So next one, use junction equation. As you can see here, we have i1, we have i2, and we just simply plug in values of i1 and i2 and we got this is value of i3, means i3 is equal to 0.85 amps, and that is also according to our previous selection or choice. So that's all for this question. I hope you have better understanding of Kirchhoff's laws now. If you are still not clear, you can come back, you can see the next part, third part on Kirchhoff's laws. But before I stop this lesson, I will also assign you one question so you can try that question first by yourself. And if you can't get the correct answer, you can come back and you can check third part on Kirchhoff's laws. So here is our next time question. So this one is next time question, means I will explain in next video on Kirchhoff's laws. So this is very similar to the question we have done right now. You just need to be consistent and you need to just follow steps. So for this one, again, you need three equations. So let me explain to you little bit few steps. Mean the physics behind this question are the physics you need to answer this question. You need to find equation one. You have to use junction. So you need to choose a junction, for example. You need to choose a junction. If you choose this junction here now, as you can see, the current entering, in this case, I1 plus I2 has to be equal to I3 at this point. So this is I1, I2, and here is I3. Okay, so and also then you need to choose a loop. For example, you can choose one loop as a left loop you can choose, and also you can choose any other loop, or simply you can choose right loop. So you have to use KCL, you have to use KVL. So here you have to use KCL, and for this one you have to use KVL. So you have to use KVL, and the next step will be simply solve them. Okay, solve equation. So this will be the last step, and you will be able to find value of I1 and I2. So I have also written answers for you. So if you will follow these steps, you will get your answer for I1 is 400 milliamps, and your answer for I2 will be 200 milliamps. If you couldn't get the answers, then just come back and search channel for third part on Kirchhoff's laws. I hope today's video was very helpful for you, and also I hope that now you have better understanding of Kirchhoff's laws.